So most planets are visible to the naked eye, all except for Uranus and Neptune. We can see Mercury, Venus, Mars, Jupiter, and Saturn. Uranus and Neptune are too far away for us to be able to observe them with the naked eye. We can, of course, see them with a telescope. You can always see them near the ecliptic, and the reason, of course, is that their orbital planes are very close to the ecliptic. Let me show you a diagram that illustrates this. Mercury, the one that is closest to the Sun, and Venus are always seen either just after the sunset, looking west, or just before the sunrise, looking east. Right? You can see them only before the sun rises or after it sets. Otherwise, because they are closer to the sun than we are, the sun's luminosity just overwhelms our eyes, so you can't see them. Okay, and Mercury is often hard to see because it's so close to the sun. But Venus can be seen in the evening, just after the sunset, or at dawn, just before the sunrise. And in fact, for a while, the Greeks thought that they were two separate objects. When seen just after the sunset, the Venus was called Hesperus. And when they observed it just before the sunrise, they referred to it as phosphorus. And then at some point they realized it's basically one and the same thing. And there's a famous statement that is often used even nowadays when people say Hesperus is phosphorus, which denotes the time when you realize that two things that you thought were different are in fact one and the same thing. Okay? Now, unlike the stars, which always move in a cyclic way, either daily cycle because of, as we know now, rotation of the Earth, or over the period of months, over the year, because of the Earth's revolution around the Sun. The planets actually do not move in a cyclic fashion, as illustrated here. This is the trajectory of planet Mars, and this diagram corresponds to the year 2000. So you see that relative to the background stars, Mars moves from west to east most of the time. But then periodically it kind of stops and reverses the motion. It moves from east to west, right? So sun moves in this direction from west to east relative to the stars, right? As we've discussed before. So do the planets most of the time, but every now and then they reverse the direction of motion. So for instance, here Mars was moving from west to east. This is so-called prograde motion. Up to October 3rd, in 2005. And then from October 3rd, 2005, all the way up to December the 12th, right? So 2.5 months, it was moving from east to west in a retrograde direction, from opposite to the prograde motion. And then on December 12th, 2005, it reversed the motion. And for this reason, Greeks called planets planets, because in Greek, planetai means wanderer. When you look at the planets with the naked eye, they do not appear too different from very bright stars, maybe brighter, right? Because now we know, because they are closer to us, and therefore they appear brighter because of the sunlight that they reflect. But if you didn't know that, you know, they look just as bright as bright stars, but they were different from regular stars that moved in a cyclic way because of this erratic motion every now and then. They move nicely in prograde way from west to east, and then every now and then they reverse the direction of motion and move in the opposite direction.